Hello guys, welcome back to my channel, and today we're gonna cover the 5I exponential growth and decay, and then I'm gonna give you guys a short summary for this chapter. Okay, and let's look at this together. So first, exponential growth and decay. They gave really fancy names, but actually it's just like what we learned before, and we try to apply our knowledge into real life. So for this one is the general form for exponential growth or decay. Okay, and the A naught, or we call the A0, is just like initial quantities, and the K is just the rate of constant. It really depends on the things you are working on with. So K for different materials, different studies, different things got different rate. Okay, and for T, just like randomly time. Okay, and for our E, it's just like natural log. Okay, it can be E or can be any other numbers, and uh, it really depends on questions. Okay, so when k is greater than 0, we just need to say it's like represent to the growth, maybe increase, so it's like growth for sales, population growth, or compound interest rate. And for k is less than 0, it's just like decay or decrease, means cooling, or means like radioactive decay. Okay, the first example they give us is a cell growth. So then we call TD. In here, it's just a generation time. So again, for N naught, it's just like A naught, and this 2 is corresponding to E over here. And this TD is just like K. Okay, it's essentially the same thing, but they just try to write in this way to help you understand a little bit. And to example 32 is pretty straightforward. They want to ask find the generation time, which is TD, to given the initial conditions. Give the increase condition from 5,000 to, this one is 100,000, right? In 4 hours growth. And in here, they convert into minutes, but if the question didn't ask us to convert, you can write your final answer in hours, it's fine, okay? But just make sure you check everything. And this radioactive K, we normally refer to the half-life, and this one is quite essential for us, to determine the date for the things, and to help us to check a lot of things. Okay, so this half-life things is quite important, even in chemistry or technically in everywhere. So if you guys find it's interesting, you can look at other YouTube videos, or even search on Google to give you the idea about how the radioactivity help us to define the date or something. Okay, but in here, we just need to make sure when you calculate for K, because K for different materials or different like element, they are quite different. And for this 33, just make sure, because sometimes people are quite confusing because they didn't really tells us the A naught is how much. We can just write A0, okay? And then you realize in here we can cancel the A naught, so A naught is not that important. But sometimes if you really want to figure out what the A naught is, you just make assumption. Okay, just make A naught is 1. Essentially the same thing, because A naught can always be cancelled. I mean, based on this situation. Okay. And another important exponential thing is population growth. Um, okay, and population growth normally we think it's with E or with 2 or with other base, but just read the question carefully to get this idea. Currently here, in this, 2020, this year, the coronavirus just spread all over the world, and it's a really tragedy, and it's really crazy, and all. And if we look at the graph, from the mathematic perspective, some of the country, like the exponential growth, which is used like this one, right? And currently Australia is getting, flat, and hopefully we going to go in here, and then we come back to our normal life. But we have to again listen to the uh, government, and listen to the medical advice, and keep the social distancing. But if we look at other like European countries, or even like America, they are just like currently still experiencing the exponential growth, and it's which is really crazy, and I feel really sorry for their people. So let's just make sure everything go back normally soon. But the point that I want to emphasize here is exponential growth and decay are quite important for the mathematics mathematicians and for the scientists to to predict or build the math model for like this situation, or for our population growth to you know reallocate the resource or any other things. So this is really important. And let's just keep going over here. 35 is a really tricky one, and I think probably it's the hardest one over here, because 35 is first they involve two things like the red kangaroo and the gray kangaroo, and then they use a word to tell you which one is which. And even the really worst scenario or worst case is how many years must the ellipse before the proportion are reversed. So basically the first time is green one, you know, sorry, the first one is the red one is 10 times of green one, but then later I want the green one is 10 times the red one, which takes me some time to figure out what they were asking. But again, just make sure you make the unknowns clear by yourselves and write this one properly. And don't worry about involved with new unknown numbers or something. Just keep doing, and you will figure out once you do the calculation, all of these can cancel with each other and to get what you want. Okay. So for 5i, it's just this one to remember, to a equals a naught times e to the k times t, or e to the k to the power of t, uh, e to the kt, sorry. And for these things, in Smash, in chapter 9, we're gonna learn how to write differential equations, and you're gonna calculate by yourselves. And in your uni life for the first year, if you continue to study math, you're gonna learn more population growth or decay models, and to help you guys to familiar with this all the things. Okay. So currently for you guys, only for the math method, you should try to the 5i to read the question carefully and solve the question accordingly. Okay. And here we come with the chapter summary. Again, for the whole chapter 5, first part is exponential. Then next part is logarithm. Later we just combine them, how to use exponential to solve log, how to use log to solve exponential, how to draw both graphs. And the first or the basic idea for this chapter, you have to familiar with index laws. For the exponential functions, you have to familiar with log calculation for logarithms. And next one is you know how to draw the graph properly, like exponential, like log. And the distinguish between them is the base. Okay, base greater than 1, and base is greater than 1, sorry, greater than 0 or less than 1. Okay. And if we want to really combine them together, we can make the inverse functions, because they are, I mean, graph is symmetrical relative to y equals x. That's the reason why our exponential function domains are range is 0 to infinity for the basic one. So for logarithm, the basic expression is from the domain is 0 to infinity and the range is r, right? And final part is our law of exponential change. So we have to read the question carefully, like the sales growth, or like the population growth, or like the radioactive decay, or even you can write like the population decrease due to some, certain disasters, or like some, I don't know, some other factors to, also use this one to, model the situation. Okay. So for 5, the tax-free problem, I highly recommend you guys try all of them to be confident about this one. Then, or we should say to be fluency, okay, in for this chapter. And for multiple choice, again, it's really good practice for you guys to know, and especially for like inverse functions, right? Over here, question 14 or 15, or even like 16 to help you guys to be familiar with this kind of things. For extended response, if you guys have time to do it, it's pretty useful. And this guy is Newton's law of cooling of object. This one is actually covered in our special. And in special, they have to know how to, I mean, to construct the differential equation, solve it. But in math method, we just directly given you. But again, you need to familiar with what's going on over here and to know the model to be familiar with, okay? So for next chapter, it's chapter 6, we're gonna cover the circular functions, okay, which is another really important part for our math method. Hopefully this video help you guys, and please subscribe and click the like button. I will see you guys for the next video. Thanks for watching. Bye bye guys.